Excellent. All right. Welcome, everyone. Thank you all for joining. My name is Darlise Calix. I am the developer marketing manager here at Devpost. And today I will be moderating. I will not be hosting, but quick context on why we're all here. Obviously, you all know this is a build session for the CockroachDB AWS Hackathon, building with agentic memory. So if you're not already registered, hopefully you do that. And if you are, I'm excited for you to be here. So you're building an agentic application that uses CockroachDB as its persistent memory layer, and we're deploying on AWS. So today's session is going to be a kind of thing to help you kind of get started, or if you're stuck, hopefully we can move you through that. So quick introduction to CockroachDB is kind of what we have on deck today. If you registered via the Zoom webinar registration, then you already got the links to some of the resources for today. And if you haven't, then I'll go ahead and drop those in the chat. But a few housekeeping notes before we jump in. One, this is a Zoom webinar, so your and camera are off by default. So if you have a question at any point, you can go down below and you should see the Q&A feature. And that Q&A feature you can use to ask any questions. So when we get to the Q&A portion of this presentation, you'll we'll kind of go over the questions, and our tech evangelist from CockroachDB will go ahead and answer those. We'll also create an FAQ document based off of the questions and answers that we talked about today. So if you miss anything, don't worry. We are also recording this session. So if for any reason you have to drop out or you can't make it for the entirety of this session, or for anyone who is watching this recording, this will be on YouTube, but this will also be sent out via email to all the attendees and anyone who was not able to attend live. If you're looking for a teammate, don't worry. We'll also have a team building Google Sheet, and I'll drop that in the chat as well. Some of our previous sessions, we kind of just did this after. I'm testing to see if it'd be good to drop it before. And so you'll be able to put in your names, your Discord usernames, skills, your interests, time zones, and what you're looking for out of a teammate. So let me know if that works out for you. I'll drop that in the chat shortly. And just another reminder, this session is actually being recorded. All right. So that's all from me. We're gonna go ahead and get started. But leading you through all of this today will be Reid, who is the tech evangelist at CockroachDB Labs, and I'm happy to introduce him and let him get started.
Hello, thank you, Dallies, and thank you everyone for joining us and for participating in our shared hackathon. So I'm the technical evangelist at Cockroach Labs. It's a title my wife hates, so I tend to call myself the show pony. I'm a professional show pony. I'm the one who gets to go all over the world doing talks about a product whose logo I literally have tattooed onto my body. So if you're looking for an impartial introduction to CockroachDB, you'll not get it from me. I'm among the world's biggest fans. So without further ado, I know you're all busy. I will share my screen and we'll just get straight into it. I've done this bit, but we'll be talking about, I actually just deleted that because I thought I didn't want to bore you. Oh, and that. Cool. So we're just going to be going through CockroachDB under the hood, just a little bit, just a peek under the bonnet, just to get an idea as to roughly how it works at 30,000 feet. And then I'll get started with a demo whose code we'll also share with you. So hopefully you've received a bunch of resources already. If not, Darlise will also be sending them out in the chat. So I'll get going. Any questions, just ping them into the Q&A. I've got it open up on the side, so I'll be able to get to them as they come in. So for those of you who might not know, CockroachDB is a SQL database which blends relational databases like Postgres. It looks and feels just like Postgres with the scalability of NoSQL and also the nativeness of cloud. So you can run it in cloud, you can run it across cloud, you can run it on-prem in a data center, you can run it on what's that legacy technology that mainframe. You can even run it on mainframe if you want. So you can run basically anywhere you need it to run. So going straight into CockroachDB, being a distributed system, you run a binary. That's the smallest unit of software in CockroachDB. It's a binary. It could be a Docker container. It could be a Kubernetes pod. It doesn't matter. But that's the smallest unit of measurement in CockroachDB. If you join a bunch of those together, you have yourself a cluster. Now, these behave, they present themselves just like a single instance of PostgresDB would look like. To most people, you just think you're talking to Postgres. However, as you add nodes to it, you're gaining read and write capacity. So fundamentally, CockroachDB horizontally scales because of the way it shards its data. You don't have to worry about sharding of data. I've manually sharded data in a past life, and I know how painful it can be. But it does the sharding for you, and it does that by splitting data into ranges. So if you imagine you had a table, you flipped it on its side and you chopped it into pieces, those pieces are called ranges. And by default, a range is half a gigabyte, similar to a gigabyte, in size. So think of it as about half a gigabyte blob of contiguous data, so sorted data. So in our example here, let's say this value 0C8AD, which contains the value vetiver, and all the way up to spice, which is 110. Notice how it's lexicographically sorted on the primary key. They are in one range. Then we've got another range which goes from 24 to 3D, and then 46 to 5E for the third range. Now, the way we scale, the way we survive outages, is that we replicate those ranges across the nodes in the cluster. So each range has at least 3 replicas by default, although you can tune that to your requirements. And that's determined by the replication factor. So by default, it's 3 for a single region database, 5 for a multi-region database, but the sky's the limit, although I don't know why you'd want to go much higher than 5. So in this example, range 1 has 3 replicas, so it's the same data replicated 3 times. And this is what it might look like across the cluster. So you don't have to worry about this. You just throw data at CockroachDB and it will figure out where data needs to be for maximum resilience, lowest latency, and just most optimal utilization of all of the nodes. So our range 1 has a replica 1 here, replica 2 here, and replica 3 here. Similarly, range 2 will also have 3 replicas, replica 3 will have 3 replicas, etc. Now, one of those replicas is special. We call it the leaseholder, and that's essentially what controls reads and writes to that range of data. So there's no concept of a read replica in CockroachDB. There's no concept of a write only or write instance. All the nodes behave the same, and they are elected. They elect each other amongst themselves using the raft protocol. So for example, range 1, replica 2 might be the leaseholder for range 1, replica 3 might be the leaseholder for range 2, etc. But there's only one leaseholder, and CockroachDB will make sure that the leaseholders are distributed as wide as possible for maximum throughput. And you'll get multiple leaseholders per node because you'll likely have hundreds or thousands of ranges in your database. When it comes to reading data, this is what it might look like. We've got our little client up here. This is the leaseholder, as indicated by this key, and these are the other replicas or the follower replicas. So they'll make a request via a load balancer. That could be hardware or software. The load balancer sits outside of Cockroach, so that's something that you would manage, say, as a Kubernetes load balancer or F5 load balancer if you want to manage it with hardware. And let's say our request, we're looking for data that exists in this range here, but we hit this node. So all of the nodes, while this node doesn't store the data that it's looking for, it knows where to find the data. So it will speak to the leaseholder that will return a consistent view of that data. You'll never see inconsistent data in Cockroach, and it will return it. Now, the writes are a little bit more involved. So let's say we hit the same node again, the leaseholder for the range of data they're wanting to write is still on node 4. So node 3 knows where it needs to write the data to in order to make it consistent. This node will write it to its disk before saying to its follower replicas, by the way, I've just written this to my disk. You need to write this to your disk as well. The first node that responds in a replica of 3, we know now that we've got 2 copies of the data. So the data has quorum, it has majority, and we can return straight to the caller to say, yes, this is written and committed. Everything's fine and safe. Asynchronously, the other node will still respond to the leaseholder, but it's not part of the critical path in terms of writes. Now, in terms of failures, and we're very, very close to the demo now, there's two types of failure. There's a non-leaseholder failure and a leaseholder failure. Realistically, everything is going to be a leaseholder failure because there will be leaseholders on every node, most likely. And not necessarily, but most likely. But this is what a non-leaseholder failure looks like. Let's say we lose node 1. So node 1 has gone down. Let's say the data center that it was in caught fire and flooded at the same time, as is what happened with the Europe West 9 data center in Paris in 2012, I think. And let's say it comes back online again within 5 minutes. By default, 5 minutes is the time that CockroachDB will allow a node to be down before it starts its own recovery process. So this node has come back up, at which point the leaseholder will say, by the way, this is what you missed since you've been down. So bringing it up to date with these replicas. If, however, it doesn't come up within 5 minutes, CockroachDB itself will nominate a new replica from the pool of surviving nodes. So bringing us back up to the replication factor of 3 that we care about. In the case of a leaseholder, it's ever so slightly different, but much the same. It's the same recovery process. Let's say we lose our leaseholder. Within, on average, 4.5 seconds, Cockroach nodes will recognize this and allocate a new, elect is the correct terminology for this. They'll elect a new leaseholder, which might be either of these, and it will start to orchestrate the reads and writes for that data. So question here, what is a leaseholder? A leaseholder is just the thing that controls reads and writes to a specific portion of data. So we've nominated this new leaseholder. Everything carries on. If that old leaseholder comes back online within the 5-minute window, the new leaseholder will say, here's everything you missed since you've been down. And again, if it doesn't, we'll start a new replica on one of the nodes. So that's it for the spiel. I obviously want to get into the code. I'm a developer. You want me to get into the code. You're developers. These are a couple of links that we can also send in the chat. This is the link to the GitHub repo that I'll be showing you now. It's different to the one we sent you before. This is just specific for today's session. And then we'll have then there's a video explorer, which I put together a couple of weeks ago just to make our YouTube videos a little bit easier to find. So with that, we'll get straight into the code. Now, hopefully my zoom level is okay and you can all see it, but this is what you'll see if you visit the URL. Now, there's a couple of prerequisites. There's a couple of environment variables. These are specific to my machine. I'm using my own personal one password, but one way or another, you'll want an OpenAI API key, a Cockroach API key, which I can walk you through shortly. And actually, you don't need an AWS profile. So there's a bunch of ways you can get started with Cockroach. The rules on the hackathon site, I think, require a Cockroach Cloud cluster, which I will show you. And there's a couple of ways you can create those, but you can also create local clusters. So if you download the Cockroach binary, it's just that the Cockroach binary is everything packaged up. So that's everything you need for a CockroachDB cluster. You can start a single node. So let's call Cockroach start single node. We'll start it insecure. I'm just running it on my local machine. I don't need TLS. I want the listen address. So this is the SQL address that your clients will connect to from code, etc. An HTTP address, which is what you'll be using for the UI. And I'll run it in the background. So I'll start that off, and that's running. Now I can come over to here. Let's start a new tab and open up local host port 8080. And this is my single node cluster. So I can view metrics for the last hour, last 10 minutes. Anything that I run against this cluster is going to show up here. Now, my data is under-replicated because I only have one node. If I had 3 nodes, you would see that this is fully replicated. Now, I'll kill that, and I'll start another cluster, this time a 3-node cluster using Docker Compose. So there are 3 nodes, node 1, node 2, and node 3, all running v2611, and they all join each other. In front of that, I've just got an HA proxy, which discovers the nodes and serves both the HTTP traffic as well as the gRPC traffic for SQL. So I will get that running. And I'll the only difference with Cockroach, the start single and the multi-node start is you have to separately initialize, which is what this does. And then, but if you're running managed Cockroach, you won't have to initialize it. It will do that for you. So I can come over to here. If I refresh this, I'll now be talking to my 3 node cluster. So I've got my node 1, node 2, node 3. They're all listening on, they think they're listening on these ports, but actually they could be listening to different ports on your machine. But I'm only exposing them through 26257, which is my HA proxy. But everything else is exactly the same. But notice here that we haven't got any under-replicated data. Each of these nodes are replicating data amongst themselves without my doing anything, just to make sure that if I kill one of those nodes, it remains online. And you know what? Actually, why not? Let's just kill one. If I do docker stop node, let's do node 2. So I've just killed node 2. You see it's offline now, but my workload would still be running. I can see from my network that node 1 isn't able to talk to node 2, nor is node 3, but everything carries on because it's running across multiple nodes. And that's what allows it to survive things like data center outages, disk corruption, network partitions, etc. So it knows it's unhealthy, but it's still online. And let me just start the node up again. It will realize that the node is come back. The leaseholder well, actually, probably both of them, any leaseholders that are on these two, will be saying to the node 2, by the way, here's everything you missed since you were offline. And now we've gone back to nothing under-replicated, and the network diagram looks healthy again. Any questions, keep them coming in, though. So next, let's just kill that. Let's do docker ps. Let's go crazy. AQ, pipe that into logs, docker remove f. So that's got rid of the cluster. And there's also one of my favorite little features of the Cockroach binary is Cockroach demo. Now you can start a multi-node in-memory cluster and provide it. You can decide on how many nodes you want. All of these will take a few resources on your machine. I've run up to about 27, I think. But you can also specify the localities. Now, what you might not know about CockroachDB is that you can run it a single cluster across the world, and we can get onto that in a minute. And you can geographically pin data where you want it and where you don't want it. So for things like GDPR, CCPA, it's important for some of our customers because it allows them to run a single cluster and manage just one cluster. I was a customer of CockroachDB myself back in 2018, 19. So I was running a global cluster with customers all over the place. But this is what it looks like. Now I will kill that as well. All you have to do there is just exit the shell and that tears everything down. But realistically, you're probably, and this is fine. This is what I would be using for local development against Cockroach. This is if you've watched any of my demos, this is what you'll see. We've got another question. Thank you very much. Great session. I'm glad to hear it. Looking past the initial setup, in a true multi-region production deployment of CockroachDB, what is the single biggest architectural blind spot teams hit when trying to balance survival goals, like region failure, against strict P99 latency SLAs? If you could give one piece of scar tissue advice on this, what would it be? Good question, Yash. Thank you. So let's say you're running a multi-region cluster. Now, you might not be for your hackathons, but let's say you're in production and you lose a region. One thing to be aware of is where your customers and your applications are. If, for example, you know what? Actually, I'm just going to share my whiteboard because I think this is probably something that makes more sense to whiteboard. Bear with. And I'm just going to switch over. This is when you think, please, technology, don't let me down. Bosh. Okay, cool. So hopefully you can hear me at this angle. But let's say you're running in the States, the EU, and APAC. You've got 3 nodes here three nodes here, and let's say three nodes here. If you've got a customer here, one blind spot I would definitely urge people against is running an application here. Because if they care about partitioning their data, but they're using an application that's over here, they'll be making a 5,000 kilometer hop here, going to the database, which is where their data is pinned, back to the application and back to them. So like 20 over 20,000 kilometers of needless hops just to partition their data. So more realistically, you'd have an application here, you'd have an application here, and you'd have an application here. Now, don't panic, people. This is just like for a large scale production deployment. So realistically, they'll be talking to their application, which talks to their database and back again, which is probably more like 400 kilometers tops versus 20,000 kilometers. So speed of light is something you definitely can't beat. We like to think of it as one of our biggest competitors. So it's a case of carefully designing your global system to achieve the best experience for the most important person. So I recently actually this we can probably share this as well, but I just dropped my pen. I recently wrote a little O'Reilly report on architecting multi-region, designing multi-region application architecture, which I can also share after the fact. So hopefully that answered your question. But yes, that is typically a blind spot. And you'd also need to be worried that if you lose this whole region, where does this person talk to next? So typically you then maybe run multiple regions within here, at which point you can geographically lock multiple regions together. So data can replicate amongst those regions, but not outside of them. So if that does go in its entirety, they still get a good experience because they're still talking to local nodes. Hopefully that answered your question. And thank you. So the next way to install CockroachDB is via the Cloud API. Now, this is just a regular API that you would make requests to. And in this case, I'm creating a cluster. And this is just a post endpoint that accepts JSON. I'm calling it CRDB AI 0 to hero. The provider is AWS. We also support GCP or Azure, but please choose AWS for this because it's a AWS and Cockroach hackathon. You can choose your plan. There's three. There's basic, standard, and advanced. Basic starts off free. So if you're looking to kick the tires of CockroachDB, you're wanting to use the CockroachDB cloud for your hackathon submission, use the basic tier. You'd still need to provide detail, like payment details, but provided you don't go over the free limits, you're fine. And this is a serverless style database, so it scales to 0. And I want to deploy it across Virginia, Northern Virginia, Frankfurt, and Singapore, with my primary region being EU Central 1. Don't worry about the primary region. I think that's beyond the scope of this conversation. So I create that. I slurp out the cluster ID from the response I got. I generate a random password. And this is just something I wrote. You could just, mash the keyboard to generate a random password. And I construct a host name and a URL using the username that I will create and the password that I generated. You can then you can check to see if the cluster is ready. And once it goes to created, you can create your user and connect. The next way I do things is via Terraform. Oh, one thing to note, you need a Cockroach API key for this, and that can be configured in the CockroachLabs.cloud. So this is the landing page for our managed service. And over in settings, nope, service accounts, this is where you would configure your usernames, the API keys that would need to configure this stuff. So if you're using either the Cloud API or Terraform, this is how you'd do it. Yash, looking at how, oh, actually, no, there's a couple. Let's have a look. We talk a lot about hardware resilience and database fault tolerance, but in your experience, what has been the hardest human or organizational failure to architect against when managing massive data layers at scale? How do you prevent teams from accidentally building themselves into a corner? So let me just digest this. So I'm going to interpret it like this. And apologies if I interpret it wrong. So one thing that I personally have architected myself into a corner with is putting all my eggs in one basket. So back in the day, this happened to be an AWS basket, although it could have easily been an on-prem, a GCP, or an Azure basket. The company had a very public falling out with AWS. There's news articles you can read about it, and we decided to move everything wholesale to GCP. As part of this hackathon, I didn't say that. We did it from GCP to AWS, let's say. And that took 2 weeks. We had help, but the whole thing took 2 weeks and was incredibly painful. So I think, in terms of building yourself into a corner, think about the technologies you're using, think about the implications of locking yourselves into them and the flexibility that you have in terms of getting out. We weren't running CockroachDB at that point, but if we were, I would have just spun up nodes in another cloud and then strangled these ones off, because that would have allowed me. So the cluster would have grown to two clouds, and then I just shut the other ones off and repoint at a load balancer. That's how I would have done it with CockroachDB. So that's the answer to the first one. The next one, looking at how AI, serverless architecture, and globally distributed systems are colliding right now, what is one technical skill or architectural paradigm that back-end engineers are completely ignoring today, but will absolutely be mandatory in order to survive production environments 5 years from now? My goodness, these are thoughtful questions. Um, hmm. Well, technical skill, everyone's going to say AI, but I don't think that's satisfactory. I think some of the biggest problems that people are going to face in 5 years are going to be keeping up. I think if AI continues on the trajectory it's going, where people are looking at things like 10, 100, even 1,000x the data volumes that they're currently seeing, because agentic AI is going to be so, rampant. They're not going to sleep. They're not going to wait for responses. They're just going to, unless you've got human in the loop, of course. So we ran a report recently where 87, I think, percent of people we spoke to, and these are like VP and up people, they reckon that their company infrastructure is going to fail under the perceived loads of agentic AI in the next 18 months. 34% of people think that it's going to completely fail within 11 months, so under a year. So I think scale is going to be a big one, and the cost economics of scaling also need to be, that's something we're looking at, because if you have 10 times more traffic, can your company reasonably afford to throw 10 times the resources at it? Like linear scaling like that doesn't work economically. So that's something that a lot of people are going to look at, but also resilience. Now, I would say that because I work for CockroachDB, whose raison d'etre is resilience. But I think there's a strong argument there, because if your application goes down and you've got 100 to 1,000 humans waiting for you, there is somewhat of a stampeding herd. But if you've got agents and humans waiting for you, that's potentially a stampeding herd that you will never recover from. And your last question, when you look back at some of the most complex real world database migrations or outages you've dealt with in your career, what is one counterintuitive lesson you learned the hard way that you'll never forget? The kind of lesson that completely flipped how you approach systems architecture today. I'm going to think about that one. I'm going to think about that one and get back to you. So, and we've got another question here. I will get to these questions at the end, just so that I manage to cover everything. So, in order to connect to CockroachDB, you run the Cockroach SQL command or subcommand using passing a URL. This is completely optional. I just do that to keep everything nice and trim on my command line. But what I'll be showing you is Terraform. So, if I look at the two architecture diagrams, I'm going to be showing you two examples. Now, feel free to use these as inspiration for your hackathon submissions. But this is a Python application which I'm using for conversational chat. So I fetch context or chat history from Cockroach. I have a TTL, a time to live which works at the row level in CockroachDB, which expires chat messages after a day. That's completely configurable. But I send that context to OpenAI in this case to have a conversation. So that's the first example. And let's do that first, actually. So I have my Terraform code. It's very simple. I bring in the Cockroach Terraform provider. I create a cluster against EU West 2, EU West 1, and EU Central 1 in this case. I create a database called example. I create a random password. That's just a name. It could be anything, but I've called it Rob because it is me. I create a SQL user called Rob with the password equal to the result of that random password. And then I output the cluster ID, which I don't actually use, and more importantly, the URL. So let's, if I run this, I'm not going to show you the URL because one of you will be cheeky. But if I connect to that, this is connected to my cloud database. So I can show regions, and that will take a couple of seconds for the first time I run it. But what that's doing is it's going away, pulling information about the cluster to present it to me. And it will show that we're running across 3 regions, one in Ireland, one in London, and one in Frankfurt. So we've got our Frankfurt region here, EU Central 1, EU West 1, which is Ireland, and EU West 2. Now, I'm running this in cloud. You can actually have a look at it here. So let's go back to my clusters. This is my Terraform cluster. It's running across Frankfurt, Ireland, and London. London is the primary region. And this is just a basic cluster. So this is the kind of cluster that you might be creating. You can see a bunch of stats. There's a bunch of metrics available as well. You can back up and restore, although we automate that as well. You can create your own backups if you want to. There's insights. So if you've got queries that are running slowly or schemas like tables that are configured incorrectly, missing indexes and stuff like that, that'll all be available here. So let's dive back into here. So that's our regions. I can also show my locality. So the locality, the node that I'm connected to, and I'm connected to the London node. That's my closest. I have configured that in the URL, but if I was hitting the global URL, it would route me to my nearest region. And this is the demo of the chat history. So I'll create a table called chat history. It will have an ID for the chat message itself, a session ID, which will track all of the messages within a given session, the message itself, which will be JSON-B. That's just a JSON blob that I get back from the agent, or rather the LLM, and a timestamp. Now, I also have a TTL, row-level TTL, based on the created at time. So when it gets to a day, if it's over a day old, I expire it, and I run that check hourly. Now, TTL expiration happens asynchronously, and it won't affect foreground traffic. So I've created that table. And if I run my application now, so I'm running my memory.python, passing in my URL. And let's take a quick look at the memory app. So it's not a huge file. I have, I'm using the limited Postgres chat message history. So you can provide a chat limit. I'm limiting it to 3. As I'm expiring rows in CockroachDB automatically, you might want to configure it differently. And then I pass in my session ID if I want to restart a session or continue with a chat session, the model I want to use. So I'm using GPT-5 Mini and my database URL. So then I enter a very basic loop, which just allows me to chat. So let's run that. So I'm in chat session EAC blah, blah, blah. And I've got a couple of canned messages that I wanted to write anyway. So I'm Rob Reid and I'm Cockroach Labs Technical Evangelist. Let's copy that session ID. So it's saying, nice to meet you, Rob. Welcome. How can I help you today? And a bunch of stuff that I didn't ask for. Now, if I come out of there, go back, start the application again, and ask it my name. What's my name? It's going to say it doesn't know my name because I haven't told it my name in this session. Whereas, I don't know your name. I don't have access to personal data about you. So let's come out of that. But this time start against session ID EAC blah, blah, blah. Ask my name. What's my name? You said your name is Rob Reid. So it knows my name in this chat session. I can ask what the name of my company is, and it will tell me. But after a bunch of times, because I'm using the limited chat history, it will forget, and that's by design. So that's that side of things. You can view the conversation history in CockroachDB. So this is the conversation that I had with the AI. There's a couple of these are the sessions here. There's my EAC session. So it knows about me. I started another conversation. I rejoined that conversation, and it was able to pick up. But eventually, that will be forgotten. Next, I'll show you embeddings. So Cockroach, like Postgres, supports vector embeddings. So I'll create another table now called social post, and that has an ID again. We recommend using UUIDs in Cockroach because it helps to distribute the data uniformly across the cluster. The value that I scraped from the social media provider, you'll see this in a minute, the time I scraped it, and the value that I embedded. So I'll create, oh, it already exists. That's fine. So now I'll export my embedding API key. You might want to use OpenAI, you might want to use Olama for a local model, entirely up to you. But what this does, and this is a Go app, I just wanted to show a bit of everything. This is a bit more involved. So there's two modes to it. You can listen, I think that's embed mode, and that's listening to Blue Sky. So a social media, quite a recent social media that came out of a bunch of ex-Twitter or ex people. They have a public facing fire hose that you can subscribe to stuff. So I listen on that fire hose, and every message I get, I embed using a model from a partner company called Takara, DS1 Fukuro, that has 512 dimensions that corresponds to the 512 dimensions in the table that I tried to create but already exists. And I embed them all, and then I write them to CockroachDB in here, just an insert into. And that's essentially what we see here. Blue Sky, fire hose into my application. I embed it, and then I insert it. So everything in that table will have the text value and the embedding value as well. So I can run semantic queries against that directly in Cockroach. And again, while it's a vector index, it is all distributed. It behaves like any other data in Cockroach. So let's run that for a bit. Okay, so we're bringing in the messages, we're embedding them, and we're writing them to the database. So we can see I'm talking to a US based DS1 model. Normally, it'd be a lot shorter round trip because it's less distance and the time it takes to write to Cockroach from my house and replicate. So I've run that for a little while. Let's ask a few queries now. So with this query, same application, but using the query mode, I can ask, let's say, what's currently happening with Greenland? And the matches are in order of their proximity based on the L2 or Euclidean distance. And these are the best results it's currently found. Any fans of Bonnie Tyler will be sad to know that yesterday she died at 75. Yep, the Welsh pop star Bonnie Tyler is dead at the age of 75. So but you can see how a plain text conversation in any language will yield decent results, and these are directly hitting CockroachDB. Everyone's probably enjoying the heat wave, which happens to be everywhere, it seems, and any data breaches recently. So let's have a look at how much data we've got in there. Select count start from social post 3,761. But again, because we've got a vector on that, we'll continue to get low latency reads and writes to that table. So that was actually everything I wanted to show you. I will stop sharing my screen and I will get to your questions. So, Yash, back to you. One counterintuitive lesson. So I think the best thing I can, in fact, I was reminded of this the other day. I was sitting in my garden, and a ray of light reminded me about my favorite production outage. Oh, you can't see it there. Hang on. If I get it. No, you can't see it. Essentially, what I have tattooed on my arm here is minus 32,768. And the counterintuitive argument is that production issues, although I've seen many in my career, sometimes it's the most disgusting, gnarly solutions that are the most elegant. And this was a very busy day on a Saturday. I worked for a sports betting company. We wrote software for a small group of professional bettors, and everything stopped working. The developer who'd originally developed the system had assumed that we'd never see more than 32,000 of a given type of event. So they'd coded it into the C# service, an int 16, and int 16 unsigned, no, signed integer, and they'd inserted it into the database as a column type of 16-bit integer. I could have fixed the database, but I'd have broken the code and vice versa. My solution was to reset the index to minus 32,000 because it would buy us about 6 months and to implement a proper fix. So I think, yeah, counterintuitively, sometimes the nastiest fix is the best. Next question. My question is more hackathon related. First question, quick clarification on what counts as an agent for judging. Our system uses a swarm of stateless workers that each make a single purpose LLM call, rewrite this file, decompose this dependency graph, and while the coordination, task scheduling, retries, and verification are handled deterministically by CockroachDB and our orchestrator code, not by the LLM deciding what to do next. So there's no React-style loop where a single LLM call autonomously picks and chains multiple tools. Does that qualify as agentic for this hackathon? I have done agentic demos myself, probably quite a few now, and they have all been an interpretation of agentic. So I wouldn't worry too much about the purity of your interpretation of agentic. The kinds of agents I've made they've made decisions. I think that's what some people require from the terminology. But I think we're open to, I'm not going to penalize anyone for interpreting an agent like that. Second question, clarification of the MCP requirement. Our usage is on the development side, not inside the product's runtime agents. We connect our coding assistant, Kiro, I hope I said that right, to the CockroachDB Cloud managed MCP server, read-only wise, to inspect the live schema and iterate over our DDL queries. Use the MCP server however you need to. If you're only doing it development-wise, that's also fine. That's the only way I actually use it at the moment. So I would say that's fine. Next question. The multi-cluster, multi-node config setup seems like a great approach to a large production problem, but I was wondering if there was a fastest path to get CockroachDB set up with AWS for this hackathon specifically. Apologies if I'm jumping the gun here, and you're showing exactly that. I'm just used to more plug-and-play DB setups like Supabase, Firebase. Yes, I completely understand that. The way I initially got started with CockroachDB back in 2016 was just on my laptop. So I think choose whichever method makes most sense to you. I know I would. If you want to run a single node of CockroachDB in AWS on bare metal in EC2, whatever it is, go with what is most comfortable to you. If you want to abstract yourself from the complexity of managing CockroachDB itself, which in itself isn't ridiculous, there's also the managed service. Go with what makes you feel most comfortable. Next question. I'm new to Cockroach, and thank you for all these questions, by the way. These are great. I'm new to Cockroach and wanted to get started with a sample deployment. What's the easiest approach? Would you recommend using Terraform? Notice you use it in your IDE, or is it simpler to start with a cloud deployment? Depends on your fluency with Terraform. I've been using Terraform for quite a while. I feel quite confident with Terraform, and the docs are really good. And I have Claude code. So I think use whichever you feel most comfortable with. Going forward, if you decide to use CockroachDB after this, and you need to make a call. Do you and your team want to manage a database, or do you want to just execute against a database? When I worked as a customer, we were actually the very first customer in the world for the managed service because I didn't want my team to have to manage a database themselves, but we weren't a team of DBAs. So again, I think use whatever you're most happy with, whatever brings you joy. Also, I guess a cluster for obvious reasons makes sense in a prod environment, but just for the sake of hackathons, do we deploy a single node? So I think I wouldn't want anyone to be penalized for just using a single node. I think if it's the easiest way for you to do it, go for it. I think the thing that I would love to see is people using CockroachDB um, and and harnessing it for AI workloads. I think you can always start small. I would never tell a customer to over provision. So start small, and you can just add nodes to your cluster when you feel confident and when you need it. So possibly start like there. But if your demo or your scenario were to need to go global, let's say, adding nodes in different locations would make sense. A lot of new agent memory systems like Supermemory, Mem0, and Zep are moving beyond simple vector RAG into evolving memory, user profiles, temporal facts, contradiction handling, provenance, graph style context, and workflow state. CockroachDB seems to approach the problem from the other direction, durable, globally consistent state. For this hackathon, what kind of memory workflows would you consider most Cockroach native? Should we focus on user profile memory, semantic vector recall, or something more production oriented like multi-agent, task state, retries, locks, audit trails, tool history? I don't mind. I think I think the beauty in all of the underlying tools will shine through the examples that you create in the first place. I think the interesting thing when people are judging these, of which I will be one, is just seeing the creativity. So if you want to, you don't have to use vector search. If you don't want to, you don't have to use vector search for RAG. You can use vector search with RAG. You can use it for recommendations, whatever makes most sense for your use case. And the last question I see here is a quick one. What kind of application are we supposed to build for the hackathon? This demo feels heavily focused on architecture. That is only the case because I'm trying to show how to use Cockroach. And I'm showing some architecture diagrams. This is just to give an idea as to two possible ways you could use CockroachDB, but it's not prescriptive. Use it however you want. And I think, as I say, I think the interesting side of things is going to come from looking at the creativity from the applications themselves. So I think that might have been it, Dollies.
I think so. I saw one more question in the chat that I guess didn't make it into the Q&A. As
Oh, okay.
AI agents become autonomous and start making thousands of decisions without human intervention, how do you think persistent memory should evolve? Should databases simply store memories, or should they eventually become active participants that rank, compress, forget, or even challenge an agent's memory before it makes a decision?
I think there's overlap. I think some things like forgetting can be handled directly for you. Other things like orchestration. So one of the demos I've done with Cockroach and agentic AI is to harness its built-in CDC or change data capture. So you write something to the database, it writes something onto Kafka or Pulsar or Webhook, wherever you set up your sync, and it will be a transactional, consistent stream of events. And you can have other agents listening on those. So that's how I horizontally scale an agentic estate. In terms of persistence, one thing I would say is the isolation level of data is going to become more important, I think. So Cockroach supports two isolation levels: serializable, which is the highest, and recommitted. That's primarily for Postgres compatibility because the default in Postgres is read committed. If you've got agents all fighting for the same data and you can't guarantee the consistency of the data, that's where issues might arise because a human might look at inconsistent data and think, that's not right, I'm going to refresh. Whereas an agent will just plow on. So I think from a persistence perspective, I would very much err on the side of stronger consistency for agents, especially if you've got a very busy agentic estate, and especially if your data needs to be always correct, like payments, for example. Anything else I would add to that?
Let's see. One last question, and this will be the last question we take before we wrap. Does Amazon Bedrock give free access to the Claude model?
I don't know. I
Yeah.
know that. So I was using DS1. Um, that does have a free tier, and it's built to work in Bedrock. Um, but I don't know. I would urge you to have a look at the various models available for the various foundational model companies available, and just pick the one that is, you know, probably cheapest or free, and does the job for this demo.
Awesome. Thanks so much. All right, those are our questions. Amazing session today, everyone. These were some pretty goated questions. Like, these were great. So I appreciate everyone who contributed questions. And for anyone who has questions, well, we have another session in the future. For this, sorry, this was it.
Um,
But
We can. I'm wondering if it might make sense to create. We've got a community Slack, and I'm wondering if it
mm,
might make sense to introduce people to that, because we can create like a channel in there for all of the conversations around the hackathons, perhaps.
that would be great. Okay, so we'll grab that link from you for sure.
Yep.
Because someone did ask that in our Discord if there was one specifically for this hackathon, and I was like, I don't think we do. So yes, we'll grab that Slack and then we'll pop it in our Discord, and we'll also send it in our external comms. You'll get an email after this as well once we upload the recording and everything and gather all the resources. All right, everyone. Again, thank you all so much for attending. This is a wrap. Rob, thank you so much for walking us through all of this. This was a really great session, and thanks for answering all our questions. For everyone here, a couple of reminders before you go. All the resources we dropped today, all the resources we talked about, the session code, the repo, the videos, the team building sheet as well. These are all in the chat, but will also be in the email that I'll send after this. Also, this session was recorded, so we'll get that to you really soon. Once I upload that, you will find it in our Discord, which I dropped the link in the chat, but you can also find it in the Devpost YouTube channel, which is just youtube.com/devposthq. And if you haven't already, make sure you register for the hackathon. I think this is a really good segue into registering for the hackathon if you're a little bit unsure. And if you were a little bit stuck, hopefully this kind of pushed you to the next stage in your build. So if you run into any questions after today, you can ask them in our Discord. But now that we will have the Slack, I highly recommend heading to the Slack and asking CockroachDB themselves. All right. Thanks again, everyone, for spending time with us today. And I hope to see you at the next build session.
Thank
All
you,
right,
Jollies. Thank you very much, everyone. Take care and enjoy your hackathons. Bye.